days or 10 days. Well, I think that could be very reasonable for a small residential project. In fact, what we're seeing right now in the past month in June, we had, I think the number was 200 applications through our simplified process, small residential systems. We were able to process about 95% of those within the 3-day requirement. So, we can execute at a very fast clip on smaller projects, but attempting to take a 5 or 6 megawatt project that is at the end of a radial line in a rural area and get an interconnection study done on something like that in 3 or 4 or 5 days, it's a little bit more challenging. So, I think there's, again, a lot of opportunity for collaboration and compromise, and I think what I would suggest or offer up to the group is that as we focus on making improvements going forward, that those types of areas will be rich with opportunity. Thank you. I'm not sure who's next.
Hi, my name's Dave Dunn. I work now with Green Mountain Power. I've been working there for just about 2 months. We were recently purchased. I was the company that was taken over, if you will. And I have to say, personally, my focus is really trying to be on renewable energy and the opportunities associated with renewable energy. And the company I worked with before was a company that gave conservative a whole new definition and extremely risk averse and certainly focused on being as accurate and specific as they could on some of the interconnection challenges. So I'm thrilled to be with Green Mountain Power. I was with the previous company for 20 years and was kind of the solo and very similar to Margaret, the customer interaction with our engineering group, with the legislature, with a variety of different aspects. So my experience isn't extremely strong in solar, although we've had some significant progressive things that have been happening in Vermont, as Andrew had said, and that going to the quick turnaround on 10 kW or less is great. As you might imagine, the engineers that are legacy to the conservative company were a little bit anxious about even letting the 10 kW go. So we have a situation where we have a very remote system in Vermont. I think Vermont's distribution system certainly pales in size by comparison to the speakers you've heard here before. A whopping 600,000 customers and on a very, very either warmest day or coldest day, about 1,000 megawatts of load. So kind of give it a new scale perspective. It's just a quick Central Vermont Public Service merged. The Green Mountain Power has a significant focus on renewable energy, so we're looking for as many ways as possible to try to streamline that process. As I said, Vermont, kind of a small place. You can see we're going to now, the actual company that took over the other company, the larger company was taken over by the Green company. Indirectly, that company is owned by a natural gas company from Quebec. So we are now covering the majority of the state, but there's still about 17 other utilities left in Vermont that may or may not be doing things differently. What does electric generation look like? We're dealing with, in the US, a significant amount of coal. It sounds like all this shale gas is going to have an impact on the amount of coal. But here's what our sources looked like in 2011. We had a significant amount of nuclear. Nuclear for us was a low-cost option when you looked at it with a certain set of lenses on, with some of the challenges that I think everyone in this room has an appreciation for, but low cost at least on the generation side. But some of the slides from previous speakers certainly talked about a lot of subsidization that have changed that. But as you can see, a pretty small percentage of solar over there, 0.1%. But majority was very low carbon emissions. As a state, we're on the order of about 1/10 of a pound per kilowatt hour of CO2 emissions, so quite low. This is what we expect by 2013, what our system will look like. We're significantly trying to focus on solar. You can see that 1/10 went up to 0.5%. We're working on focusing on getting more solar developed. But you can see what happened to nuclear. Went down to 6.5%. Our lone nuclear plant in Vermont, we didn't pick it up and move it out of Vermont. We just told them we weren't going to buy their energy anymore. So it is no longer a significant part of our power supply. In fact, that 6.5% is actually a nuclear contract with a separate entity. That opens up this other category, which happens to have a higher carbon impact. So We need to focus on turning other into something more local, more renewable, to have to get our what will probably become a pound per kilowatt hour from the 1/10 of a pound per kilowatt hour. How do we make choices? You know, as a state, Vermont was very good about having a low carbon mix, and we've always focused on making it reliable, environmentally sustainable, and affordable. You know, a fairly significant amount of in-state hydro. We do buy a significant amount also of the hydro out of Canada from Hydro-Quebec. Okay, this is our solar production. We've actually tried to look at data and help our engineers become more focused on what are the challenges of solar interconnection. When we first started dealing with the previous company's conservative engineers, there are a lot of focus on how do we get this installed, and there were some, because of the unknowns, some significant fears about how are we going to deal with those bright sunny days with the clouds, variability, how are we going to deal with some of the challenges of an ungrounded source. How are we going to deal with the day that when we need, you know, a significant amount of production, we have certain days like this. So being able to balance that and understand the value of when those kilowatt hours and when that energy is available, we're trying to look at, try to get more in, try to get our system built. Our system, we have historically had a requirement of customers who are going to put in anything larger than a 5 horsepower motor on a single phase line to ask for permission. So a 10 kW solar array, you could see would have a similar impact as a 7.5 or a 10 horsepower motor as an intermittent source. So we've had some power quality issues, and you might imagine we've got central station, we don't have a network system. We've got lines that go 11, 12, 15, 20 miles. We wouldn't even still be in Manhattan. You know, we'd be in New Jersey, and the impacts on some of these smaller areas. So when we talked earlier, folks were saying, well, maybe in one state, I've got one fast food producer, and the cost to interconnect a solar generation site on their roof may be different than the same fast food producer in a different town. We have, you know, a significant amount of challenges. We have a 2 megawatt project that is a solar project that's independently being developed in Vermont, and that is in a town that has about 600 kW worth of load. So we have some challenges to deal with that. And that's one of the things that I think the utility who's willing to work with the industry can kind of help. And one of the pieces we're trying to put in place is a map that not only looks at our transmission resources and where we could possibly install these systems with the least resistance, get them permitted quicker. We're going to try to take it down to the distribution level, use some of our SIME modeling to find out the path of least resistance. We found developers go out, don't give us a call, they're going to find the best resource from a property standpoint. What does it cost to acquire that piece of land without thinking about, oh, that's a $600,000 interconnection cost. So working together and having conversations early on, I think, is one of the keys. Other pieces in Vermont that have made it easier for solar, the feed-in tariff. We have a feed-in tariff in Vermont that has provided as much as 30 cents a kilowatt hour. It's presently set at about 27 cents a kilowatt hour. There's 7 solar projects with 5.5 megawatts. We have as much, we have 2 or 3 2.2 megawatts. The feed-in tariff was capped at 2.2 megawatts, and with a total program of 50 megawatts, there's about 180 megawatts of solar that signed up when they heard it was 30 cents a kilowatt hour. So the 50 kWq filled up pretty quickly. We also have net metering. Just in the Green Mountain Power territory, we have about 9 megawatts of capacity. In little old Vermont, about 1,145 different facilities, most of which are solar, some small wind, and actually 1 hydro. For those of you interested in technology, this happened to be a water supply for a small community. It went from a reservoir down a hill into a town, and this is just a pressure turbine that spins and gives the water treatment plant a little bit extra energy. Thank you. I look forward to the continuing conversation.
Good afternoon. I'm Jeff Irish. I'm with Hudson Solar, formerly called Hudson Valley Clean Energy and Adirondack Solar. And we are right on the ground here in New York. We're the ones who experience all these soft costs. We do sales, design, installation, and service for residential approaching about 1,000 systems now. We deal with 4 utilities: Orange and Rockland, Central Hudson, NYSEG, and National Grid. We've permitted with more towns and jurisdictions and other things, organized things that I can count. Everything from the U.S. Army all the way down to the town of way, way yonder. And there really is a town way, way yonder in New York. And this building inspector comes to work Tuesday mornings from 7 to 9. So you can imagine the cycle time dealing with something like that. We've been doing this about 10 years in New York State. We run the company like we want to do it for another 10 to 20. So we do not use Chinese modules because I don't believe they're going to last, unfortunately. So interconnection costs. I'll talk about utilities first. The